All right, welcome to part two of our video on quadratic functions. In this video, we're going to look at converting between standard and general form of a quadratic function. So our general form for our quadratic functions is f of x equals ax squared plus bx plus c, where again, a, b, and c, the constant c and coefficients a and b, are real numbers, and a can't equal 0. If it did, it would be just bx plus c, which is not quadratic, it's linear. The standard form, which we saw a lot of in the last video, is f of x equals a times x minus h in parentheses squared plus k. So example 1 had our functions written in standard form, also known as vertex form. So if you hear vertex form for quadratic functions, it's the same thing as standard form. And they call it vertex form because it helps you identify the vertex coordinates very quickly. So it's h for the x coordinate of the vertex and k for the y coordinate of the vertex. And again, just like in the last video, whatever's after the x inside parentheses, just take the opposite of it, and that'll give you your x coordinate of your vertex. So that's what this negative sign in front of h means. Take the opposite of what you normally see there, and you'll get your value for h in the vertex. And again, a is not equal to 0, and a, h, and k are real numbers. So we'll primarily be dealing with real numbers for the remainder of the videos in this course, but just to make note of it. So to convert from our general form, ax squared plus bx plus c, to our standard form, a times x minus h in parentheses squared plus k, first find the vertex. Now there's two different ways you can do this. The x coordinate of your vertex using ax squared plus bx plus c is to take negative b and divide it by 2 times a. So you might remember this from the quadratic formula as part of the quadratic formula. And then to get the y coordinate of your vertex from ax squared plus bx plus c, just plug that x coordinate in to the function. So that's the old way of doing it. I call it the old way of doing it. And there is another way, and that's to use graphing technology. So you can use graphing calculator or some kind of graphing technology to graph it and find the vertex pretty quickly. Either way you slice it, you'll have your vertex, so you'll have your h and your k. And notice the a that's in front of the standard form here, a times x minus h squared plus k. The a that's in front of this form is the same a that's going to be in the start for the general form. So you're just going to use the same value of a that you see in your general form. So example 2, convert each of the following to standard form. We have f of x equals x squared minus 4x plus 3. So first thing, let's find the vertex. Doing it the old way, negative 4 divided by 2 times a is 1. And that gives us an x coordinate of our vertex at 2. To get the y coordinate, plug that into our function. 2 squared minus 4 times 2 plus 3 gives us negative 1. So our vertex of this function is at 2, negative 1, which we could also graph this function and using the technology that we have available to us, also find the vertex to be 2, negative 1. So in our original function here, a is equal to 1. So we have f of x is 1 times x minus 2 in parentheses squared minus 1, or just, since it's a 1, we don't have to write it. So this is the standard form of f of x equals x squared minus 4x plus 3. Part B, we have g of x is 6 minus x squared. Let's first rearrange this so it's negative x squared minus x plus 6. And here's our graph of our function. So if we use the graph, our vertex, or we could use the same method we did for example 2a, but our vertex we can find to be negative 1/2 and then 25/4, or negative 0.5 and then 6.25. The value of a is negative 1, so plugging that into our standard form, we get negative 1 times x plus 1/2 in parentheses squared plus 25/4, and there we go. So I mentioned in the last video at the beginning that the y-axis for f of x equals x squared splits the graph into 2 equal parts, a left half and a right half. And that line that goes to the vertex of your parabola that's going to split it into 2 equal halves is called the axis of symmetry. So the equation for that is, since it is a vertical line, vertical lines have the equation x equals wherever it hits the x-axis. And it's going to hit the x-axis at the same x-coordinate as the x-coordinate of your vertex. So your axis of symmetry equation, just look at the x-coordinate of your vertex, and it's x equals that number. Again, remember, vertical lines have the form x equals a number. So in this case, we have negative 1/2. So it hits it at negative 1/2. The equation of this line of symmetry is x equals negative 1/2. All right, now we're going to go backwards from standard form a times x minus h in parentheses squared plus k to general form ax squared plus bx plus c. And to do that, you really just do the math. You multiply out your parentheses, distribute the value of a, and then combine like terms with k. So example 3, I believe, is our last example. We're going to convert g of x equals x plus 2 in parentheses squared minus 3 to general form. So what we want to do is we want to multiply out x plus 2 times x plus 2. We get x squared plus 4x plus 4. And then we'll copy this minus 3. There's really a 1 in front of the parentheses, but if there was a different number in front of the parentheses after we multiplied out x plus 2 squared and got x squared plus 4x plus 4, we'd have to then multiply the x squared plus 4x plus 4 by whatever number's in front of the parentheses. We'd have to just distribute it to those 3 terms. But since there's now, we don't have to worry about that, and now we can combine like terms. The 4 minus 3 gives us 1, so this function in general form is x squared plus 4x plus 1. And if you want to check to make sure that's right, just graph the problem you started with, graph what you ended with, and if they're the same graph, you're good to go. All right, so that about does it for this video. Thanks for watching, and I'll see you next time.